Hello students, our next topic is nuclear detectors. So, nuclear detectors. The evolution of the techniques of nuclear radiations detection has played a vital role in finding the mysteries of atomic nucleus. So, in order to find what is inside the atomic nucleus, we need the study of nuclear radiations. So, nuclear radiations are to be detected in order to study inside our atomic nucleus. So the radiations coming out of the nucleus such as alpha, beta and gamma are the signals which carry with them the information about the properties of the nucleus. Hence, their detection and measurement are of prime importance in understanding the structure of the nucleus. This is the need of study of nuclear radiations. The principle of nuclear radiation detection can be broadly divided into three classes. First one is methods based on the detection of free charge carriers. So by detecting the free charge carriers, we are analyzing our nuclear radiation. So this process is like this. During the passage of an ionizing radiation through a medium can be solid, liquid or gas, both positive and negative ions are produced. Since ionizing radiation comprises of charged particle moving with high velocity, the method is primarily applicable in the case of charged particle detection. So this method is mainly applicable in the case of charged particle detection. Uncharged radiations like gamma rays or neutrons can also be detected by instruments based on this method, since they usually eject charged particle which then cause ionization in the medium. Okay, so the instruments are based on this method include ionization chamber, proportional counters, GM count, Geiger-Müller counters and semiconductor detectors. Second method is methods based on light sensing. These are also applicable for both charged particle detection and the detection of charged and uncharged radiations. Instruments based on this method include scintillation counters and Cherenkov detectors. So the third category is method based on the visualization of the tracks of the radiation. These are applicable for the detection of charged particles and include instruments like the Wilson cloud chamber, bubble chamber, nuclear emulsion plates, spark chamber and solid state track detectors. Hybrid detectors combining both methods, both ionization method and light sensing method have been used for special purposes. There are hybrid detectors which combines more than one of these methods. Now, how is the detection of free charged carriers? Methods for the detection of free charged carriers. When an energetic heavy charged particle moves through a substance, it loses its energy by repeated ionizing collisions with the atomic electrons in the substance. In each collision, a pair of positive and negative ions are produced. The negative ions are usually electrons. In the case of solid medium, instead of a positive ion, a positively charged hole is created, since the positively charged ions are immobile in the solid medium. So they create charged holes. So the positive and negative ions, including the positive holes, are the charged carriers. These are the charged carriers. This ionization process is known as primary ionization. Okay. Now the positive and negative electrodes placed within the detector. Inside the detector there will be negative and positive electrodes. They attract these oppositely charged ions produced in the medium between them, which give rise to an ionization current. So these newly formed positive and negatively charged ions or holes get attracted towards the positive and negative electrodes, hence producing an ionization current. This can be recorded by a suitable measuring device to record the event. That is the passage of the particle through the medium while moving towards the electrodes. While moving towards the electrode, the ion suffers a repeated collision with the atoms in the medium. Okay, again it suffers some collisions with the medium while it is moving towards the electrode. Now, if the potential difference between the electrons in the detector is sufficiently high, then the primary ions produced in the medium may gain an amount of energy high enough to produce another ion pair. So these ions may produce, if it has enough amount of energy, it can produce more ion pairs which will also move towards the opposite electrodes. These in turn may produce further ionization by collision. These are called the secondary ionization. Okay, those first primarily ionized ions, if they give rise to another pair of ions, such a process is called secondary ionization. So all the secondary ions thus produced adds up with the primary ions, and thus an amplified current is recorded by the detector. This process is known as gas amplification. Examples are ionization chambers, proportional counters, Geiger-Müller counters, and semiconductors are based on this method. This is the same method used in these counters. Next, our first topic is ionization chamber. So this is the ionization chamber. This is the ionization chamber. It is the simplest form consisting of a hollow conducting cylinder closed at both ends with a window W at one end for the ionizing radiation to enter. So this is a cylindrical shaped ionization chamber. This is fully closed, and there is a window through which the radiation is let in. Okay. Now a metal rod R, you can see it here, metal rod R, well insulated from the cylinder, is mounted at the axis of the cylinder. So this is mounted at the axis. A potential difference of several volts is applied between the cylinder and the metal rod. So in between the cylinder and the metal rod, you can see a high potential difference, several hundred volts potential difference is applied through a resistor. The positive terminal of the potential to the metal rod through the resistor R, and the negative potential through negative potential to the cylinder. The cylinder is filled with a gas, usually of air or hydrogen, at atmospheric pressure or at greater pressure for gamma ray detection. So this chamber is filled with either air or hydrogen, or for greater pressures for gamma ray detection. Fill it with either at atmospheric pressure or at greater pressures. For the detection of neutrons, boron is introduced in the form of Beer. So for detecting neutrons, boron is introduced. Now when the radiation enters the chamber through the window, it produces a large number of ion pairs. Positive ions move towards the metal rod, which is positively connected, and the negative ions towards the metallic cylinder. In order to count the particles, the pulses of currents produced are fed to an amplifier. So the primary ions as well as the secondary ions produces an ionizing current, which will be amplified and detected by the pulse counter connected here. This is a simple mechanism for the detection and counting of radiations by the ionization chain.